Hey everybody, I want to walk you through the procedure for the lab, the enzyme catalysis lab we're going to do on Monday, where we are, instead of using toothpicks, going to actually work with real enzymes and substrates and see how fast the chemical reactions go with normal enzyme, and then do torturous evil things to the enzyme and see what that does to its ability to carry out a chemical reaction. I want to show you just the basic apparatus so that you have a sense of what you're going to do. It's just me here with my one hand able to hold the camera, and the other hand able to do work, so forgive me if I jump around and make you nauseous and want to throw up. The apparatus looks like this, and you have a tub of water, you've got the graduated cylinder on the ring stand. What we need to do before we do anything with our actual chemicals is we need to submerge this graduated cylinder into the water. So let me show you how we're going to do that. We're going to take it out of the ring stand. Okay. And we're going to completely submerge it. Okay. Completely submerge it, and you want to have no air. You want it to get filled up with liquid only. So that sometimes is a little tricky to make sure you don't get any air bubbles. Sorry, I'm filming space here. Okay, so I've submerged this and I have nothing but water in my graduated cylinder. And now I'm going to pull it out and I'm going to put it in the ring stand, but I'm not going to allow the end to come out of the water, which means my water is trapped up in the graduated cylinder, and that's exactly what we want. So I'm going to screw this down tight. Okay. Now the reason we want this is because of what we're going to do next. What I want to do is react my real enzyme and my real substrate. In this beaker is my real enzyme. This enzyme is called catalase. Almost all living things have catalase. And the reason almost all living things have catalase is because almost all living things create hydrogen peroxide as a toxic byproduct of their everyday metabolism, their everyday chemical reactions. Hydrogen peroxide is extremely toxic. Therefore, if you're creating it as a waste product, you better get rid of it. Catalase helps cells get rid of it by breaking down toxic hydrogen peroxide into two substances that are not toxic, and those things are water and oxygen gas. So those are the products of the reaction of this enzyme with this substrate. The products are water and oxygen gas. To measure how fast this enzyme is able to break down that substrate, we're going to measure how much product is made. Think of it as we're going to measure how many broken toothpicks are made. Our broken toothpicks in this case are oxygen gas and water. We're not going to measure the water, we're just going to measure the oxygen gas. And that will tell us how fast our reaction is going. So what we will do is, after you've set this up, you've got your reaction chamber, which is this big test tube, and the stopper with tubing, and you're going to take 10 milliliters of hydrogen peroxide, and I need my glasses on, and I'll pretend I actually measure this correctly, and I overdid it, but that's okay. And we're going to, forgive the camera work, I have no idea if you're seeing this, but we're going to put the 10 mLs of hydrogen peroxide in the reaction chamber. And now that it's in there, we are then going to put 1 ml for our standard baseline reaction. We're going to put 1 ml of catalase. And if you look, my pipette is graduated so that you can see 1 ml is this top line right there where my thumb is. So 1 ml. And we're going to place that in the reaction chamber. Let's pretend you just saw me put the 1 ml in there. Okay, so if this were actual catalase and hydrogen peroxide, right now you'd be seeing bubbles in here. because that would be the oxygen gas being created. But I'm faking you out. I just put water in because I didn't want to waste the enzyme. So now, what we would do to get our reaction chamber completely ready is we would take the stopper and we're going to put the stopper in the reaction chamber. And now what we're going to do is we're going to place the whole thing. Now remember, if this were real, this would be producing oxygen gas, bubbles. What we want to do is find out how much of this oxygen gas is being produced, how much of these bubbles are actually being made. So we're going to put this in the water, submerge it, and someone may have to just keep holding down the reaction chamber so it doesn't float up. And then you would drive the tubing from the reaction chamber, you can see that, up into the graduated cylinder. And any gas that is made in the reaction chamber will go up into the cylinder and push out the water so that you'll be able to measure exactly how much gas is being made as the water is pushed out of here. You'll get more and more gas taking its place, and you'll measure 10 or 20 or 30 or however many mLs of gas volume is made. And you will do that straight reaction for, you're going to measure the intervals, 30-second intervals. You'll measure how much gas you got at 30-second intervals for 5 minutes. Then you'll take your reaction chamber, clean it out, and then you're going to do part B, which is where we test for enzyme concentration, the effect of that on our enzyme activity. So that's your little setup and how you would do it. And I have no idea if that turned out. So I hope it did, and I hope you didn't throw up. I hope you have a great weekend. See you on Monday. Nighty-night.